So, thank you all for attending today. Firstly, I'd like to introduce myself. This is our introduction to machine vision. I'm Tony Bowyer. I've been doing machine vision for 25 years, thereabouts, showing my age. We are Automation Systems and Controls. We're a Cognex automation solution provider, so we have access to selling all the Cognex products and assisting, providing solutions with their gear. Today's two parts for today. I'm going to do a bit of an introduction into the vision fundamentals, so the different aspects of machine vision and things you need to consider when looking at machine vision. And then from that, I'm then going to go to the software and run through the Software Insight Explorer through that. So initially we start off with vision fundamentals. So with Cognex, they have a huge range of different products, starting with, at the bottom end, the Insight 2000 series, which is fairly small, very flexible, different lighting options. Then we go up to the Insight 7000, 8000, there's a 9000 range that's just been brought out. And then to the higher end, we have what we call Vision Pro, which is a PC-based vision system as such. It's where you have dumb head cameras and you run the software on a PC like the laptops you're all looking at here. And it does all the processing. The software that I'll be looking at today is the Insight Explorer software. It's for this ranges of cameras at the bottom, the Insight range, from the low end to high, medium. These are the cameras that are very easy for setting up, easy to understand, and the software is free. It's another advantage. You can have a bit of a play and see what's possible with it. Going up in complexity, goes up in price. So what is machine vision? They're computers that see. So here's a camera, we have a lens. So what are the components of a machine vision system? Field of view, what are we looking at? We could look at a human hair, we could look at a car tire, we could look at an aeroplane wing. So we need to look at our application. The lighting is another aspect, another component of machine vision. The lighting, there's different techniques to make our part look the best. Then we have image acquisition, that's the camera taking a picture. Then we have the vision tools. So the vision tools evaluate the picture to make a decision. And that's the software that we'll be looking at shortly. Last but not least, part of the vision system is the communication, sending decisions to other devices, pass, fail, good, bad, checking the number of products, whatever it is. Machine vision is more than taking a picture, it's evaluating the image and taking action. So we evaluate the picture and take action, make a decision. So the first component that we look at is a field of view. How much can we see? So there's two factors that determine this: the working distance, the distance your part is away from the camera, and the lens that we choose. So depending on the lens that we choose, it has a different angle associated with that. So if you do search online for the Cognex Lens Advisor, it will help you calculate the working distance or the field of view that's produced. For the Insight 2000s, there are charts that come with the reference guide. So what will affect my image? And this is something that you need to be aware of when looking at an application. Virtually everything will affect your image. If you imagine your image is outside, you could have different lighting, shadowing. So different light color will affect your image and change the image. Filters on the lens and the light intensity, if it's getting brighter or darker, that will all affect your image. The light direction, if it's coming low down, it'll create shadowing. The object distance, if the object's getting closer or further away, if you were measuring something, it's going to change, because it's like if you move your finger closer to your face, it's going to appear bigger. Closer to your face, further away, it's going to appear smaller. It's the same with the camera. So there's lots of things that we need to consider when looking at an image, because we want consistency. And I suppose this is where different lighting techniques will help to give us consistency. Getting a brighter image can be useful sometimes with a lens. And then we can close the aperture off and we can have a greater focus or depth of field, as they call it. Can increase your exposure time. So a brighter light means a shorter exposure time, which will mean if your part's moving, we get less blurring. I forgot to mention at the start, please, at the end, I'll take questions, and there's a chat box you'll all notice there. If you want to hit that at the end, and I'll give everyone time for asking particular questions. So lighting techniques are critical. When it comes to machine vision, the image, we don't want it changing. We want it to be consistent so that we can look for variations in the part and not see variations in the environment. So with lighting creates contrast. Whatever it is we're looking at, we want to have a good contrast of our part compared to the background. Lighting creates part-to-part image consistency. So as the parts are coming through, we want to see those parts consistently. Lighting also minimizes ambient light interference. We don't want the image varying. We want to control as many factors as possible, because that will then give us a rugged, reliable vision system. So, because we want to look for variations of the part to see if the parts are good or bad. The last statement here, lighting is not an exact science, and that is so true, because sometimes, depending on what we're looking at, we may need to try different colored lights, different angles of lights. It's all about creating the biggest contrast possible. But as we can see at the bottom, lighting is fundamental to all machine vision applications. For all those reasons above, it gives us contrast, it gives us consistency, minimizes ambient interference. So lighting is 100% to give us that repeatable system. So different lighting techniques we have. We can backlight a product. Backlighting is really good for if you're measuring parts, if you can. Gives you really good sharp edges, really good contrast. You can use polarizing of lights. You go to the beach, you put your polarized sunglasses on, it removes the glare. Easier for us to see what's going on at the beach. Same thing for the cameras. The reflections can interfere and can be unwanted. So that's where polarization technique can help. We can use laser lines, and those laser lines we can project onto our product, and that will give us a third dimension. So we can effectively work out a Z axis. And bright field lighting is when you've got light coming down high from the top. It tends to flatten out our image. Dark field is when it's less than 45 degrees, you create an angle and it highlights lumps and bumps. A good technique to create greater contrast when there is none. Then we have our diffuse domes and axial diffusers. There are other lighting products that we have available for looking at highly reflective products. So if you were to look at the bottom of a Coke can and you're printing on that, it's reflective. You know, you would just have reflections everywhere and you wouldn't be able to see that the date code is present or do an OCR. That's where soft light from these diffuse type products can be very helpful. Just as a couple of examples to highlight that, on the left we have a lamp filament. Hopefully it's not flipped around for you guys. Sometimes the video is. On the lamp filament, if we're looking at this filament with a ring light built into the camera, you're just going to get a lot of unwanted reflections. On the right-hand side, we have a lamp filament with a backlight and beautiful contrast. You could measure the distance. If you had enough resolution, you could count the number of windings in the element. So it just shows you different lighting techniques can make or break applications. There again, here's on the left, we're looking at the lid of a product, grape jam. Ring light shining straight down, you're going to get reflections going bang, straight back into the camera. So there's no way of deciphering which barcode, which lid. Have we got the right lid on the right product? You can't see it. Whereas on the right-hand side, using polarizing, we have the ability to, no, we've got a good image. We can read the barcode. We could check the brand, it's Welch's or whichever grape jam, it's the correct raspberry, strawberry that we need. Different lighting sources we have available to ourselves for applications. Fluorescence for larger area, not so much used nowadays, not that bright because the LED technology is #1 for machine vision, and we have lots of different options and the cost has come down quite considerably for larger areas. You can have different shapes, different colors, quite a good lifespan out of them. You can strobe them, so you get maybe 9-10 years out of LED light sources. Different colors can be useful to highlight and give you greater contrast. Doing OCR applications, we use a lot of red light. We're using a specific bandwidth so that we can have sharper characters. So it all comes back to the application that we're looking at and what we need to do. We can use light at the UV spectrum to highlight whiter products, or maybe we have done UV printing on some applications and then we use UV light to make it stand out so we can do an OCR, read a code that's being printed. All the way through to, you might have on a production line, you need lights on there and you need them flashing to get extra brightness. You don't want to interfere with the operator, so we've used infrared light, which is in a spectrum that humans can't see, but the part will be highlighted. The camera can still see at that wavelength. So there's lots of different options. I've got lots of rules of thumb for those of you who have done my full training courses. You know, if it's a square part, I generally might use a square light source. If it's a round part, could be a round light source. Every light source has its particular pattern that it puts out. And then these lights can also be angled to give us greater contrast. So we've looked at field of view, we've looked at lighting techniques. Image acquisition. going to look at with the cameras. So with any of these cameras, behind the lens is an imager, a microchip that converts the light energy into digital pixels. So the digital information is a pixel. There's our pixels. Cameras come in different resolutions, 800 by 600 for a 0.5 megapixel, which is fairly standard nowadays, or we go up to 5 megapixels. Recently, I think we've released in this smart camera range 12 megapixel type cameras. So close up of a pixel. So every pixel, each pixel has the following information in the image. It has a row, a column, or an X and Y, and a level of light intensity. So if we were to look at this blow up of this section here, you can see, like, if a pixel is fully off, it is 0, going through to fully on 255. It's an 8-bit grayscale. So somewhere in the left-hand corner, we have row 2, column 3, a grey value of 255 because it's fully white. Over here, row 16, column 15, or X and Y, grey value 0. Somewhere in between, we get a grey value of 87, 8-bit grey. Now, this is a mono camera. Most, I'd say 70% of cameras we sell would be mono or grayscale for applications. The rest would be colour nowadays. In the past, colour and grayscale cameras, the colour ones were more expensive. Nowadays, same price. It's just really a matter of what's right for your particular application. What you got to remember with a colour camera is you have X, Y, and then you have RGB. So you have a lot more information, and with that, processing time is slower. Something to keep in mind. Where pixel resolution becomes important when selecting a camera, it could be if you've got quite a large field of view, you need to read a barcode. Some of the tools need a particular number of pixels to work. So to read a barcode, you need at least 3 pixels to read the thinnest bar. So that might be when your barcode is quite long, like in this instance, you might need to go to a higher resolution so you've got enough data. Also, with reading OCR, my rule of thumb is I want my character height to be 20 to 30 pixels. If it's not, then your character won't be made up of enough pixels, so you won't get a good, reliable read. Also, you can imagine resolution would be important if you were doing measurement. So you want to measure something to a particular accuracy, you will need to have enough pixels to be accurate there. So vision tools. So what are vision tools? The vision tools are software algorithms that are the building blocks of all vision applications. So we'll be looking soon, probably another 5 minutes, we'll be starting to look at the software, which is a bit more interesting than just looking at boring old slides. So vision tools analyze a specific set of pixels within a defined region of interest. They show graphics of what's being analyzed and report data so that we can make a decision. So that's what it's about. It's about looking at the image, analyzing the pixels, and making a decision. The different types of vision tools that we have, there's image processing and filtering, positioning, locating. Very important to be able to locate your part consistently so you can look at it. We have counting tools. Have I got 10 fish fingers before I put them into the box? I know I get upset when I'm missing a fish finger. Measurement tools. Is the cap properly screwed down? Then we have other application-specific tools such as barcode reading, defect detection, looking for scratches, color recognition. So all the tools vary depending on which product line you're looking at. So just to give you an idea, quickly, we'll look at this in more detail when we look at the software, but image processing filters. You can process the image to enhance, to give you a greater contrast of what you're looking at. Positioning tools, you know, as things move around in the field of view, you can position them. If you would like, at the end of this, I will email these notes off to everyone. So never fear about if you need to write down notes. This PowerPoint I will send off to people. Then we have the PatMax tool, quite a good tool we have in the Cognex suite. It's where you train a part. It's a pattern-based tool, but it's a geometric pattern. So when you train in this spanner, it doesn't train in the whole spanner. It's training in the outline of the spanner. So that gives us a lot of advantages. It enables us to handle contrast changes, even to the rate of being a negative. It can even pick up in very low contrasting areas. This tool's been around for a very long time and was great in the automotive industry when you're trying to find silver nuts on a silver engine block or a silver background. Can handle rotation, can handle occlusion or overlapping. So it doesn't need to find, because it's a geometric outline, doesn't need to find the whole shape to find it. Hence, where it's not finding it, you can see it highlighted red. It also handles scale, but very reliable to find parts under tough conditions. And to be able to analyze your product in most applications, you want to be able to lock in so that all your other tools aren't moving around and they're looking in the correct position. So there's counting tools, whether it's counting the number of LEDs in this pattern, or you can do color pixel counting. Measurement tools, measuring. I must apologize for the speed on these slides. They're quite fast, but measuring parts or measuring the thickness of glue. A lot of these applications we've done here in Australia. Glue bead, measuring the width of glue, so lots of distance measurements tools. Or down here, label inspection, making sure the correct label is on, but also the placement of that label in the X, Y, and theta. Barcode reading, 1D, 2D, OCR, so that's what we call our identification tools. 2 more slides to go. Communications. So we've got digital inputs, digital outputs. So they're used for triggering or sending pass-fail. So into the camera, you send a trigger. Coming out of the camera, pass-fail. Alternatively, we have serial and Ethernet communications. So there are different protocols to talk to PLCs, operator interfaces, data collectors. We've got a lot of the most common ones, Ethernet IP, Profinet, Modbus TCP IP, MC protocol, CC link for your Mitsubishi products. Now, my favorite slide to end off on. Now, there's all these different components to a machine vision application. Now, I like to call it a vision system, because it's not just a camera, or it's not just the software that we'll be looking at momentarily. It's a system, and there's lots of things to consider. For instance, the part arrives at the station. How are you presenting the part? Is the part going to move up, down? Is it going to be consistent? So in this particular application, if we're measuring the diameter of the bottle tops, there's a great contrast. It's a white bottle top on a black background. But the customer might say to you, well, yeah, but I do black bottle tops. So it could be a matter of changing the conveyor. So change the conveyor to blue. That way, it doesn't matter if it's white or black bottle tops, you've still got a contrast. Then the customer says, well, I do blue bottle tops. Okay, need to think outside the box. Maybe we backlight it. So have a PVC conveyor, put a backlight underneath the conveyor. That way you would end up with a silhouette. So the point I'm trying to highlight here is there are, how you present the part can make or break applications, and you may need to change the environment to be able to inspect the product correctly. Next, how are you going to trigger the system? Is the PLC going to send a trigger when the product's there, or is there a photo eye, something like that? The illumination, the lighting, as we talked about before, very important to give us that consistency. The image is acquired, so that's the camera getting the image in. It's going to take some processing time, something that we need to consider. How long do we need to process? The vision system will then work out good or bad. What do we want to do if it's good or bad? Do we want to put in a diverter, a blow it off, push it off the line? What are we going to do? Stop the line. Sometimes people want to do. Next, do you want a display to show the operator the rejected parts, show them stats, whatever else? So as you can see, that's why I love this slide. There is just so much to consider in a vision system, and it's more than just selecting a camera, a lens, and whatever else, and the software that you use. It's about looking at the whole environment, the system in total. So you will notice the slides do go on. I'm not going to go into the vision applications that we have. I'm going to jump into the software. That's where you can have a look at these at your leisure. As I mentioned, we'll send out a copy of these slides to everyone, and you can go through. There's some quite good information, different applications you can see there. Whatever it is you want to do, lots of different applications that are being done before. Just going to change over now to my Insight software. So this is our Insight Explorer software. There are two programming environments. Make that bigger. Two programming environments. This is the Easy Builder environment. It builds an application into the spreadsheet, which is another programming environment behind. Today, I'm just going to show you the software of the Easy Builder. It's more of a configuration environment, and you will see that as I go through here. Another 20 minutes or so, we'll go through this. I'll show you a couple of different applications, and then I'll take some questions or maybe show you specific things from this. So it is a Windows-based program. So you will see up the top here, standard file, edit, system, window, help. They're standard window type drop-down menus. What you have here is image, sensor, and system, and they relate to the camera. But under file, you would find something what you would normally expect. New job, open job, save job, open an image, save image. Standard things. Under edit, undo, redo, cut, copy, paste. Standard. And under window, you can tile horizontally, cascade, or alternatively under help has all your access to your help. As I mentioned, the hotkeys we have here are also found in the drop-down menus. So if I were to go to image, you can see we have trigger, record, playback options. They're the same as different hotkeys here. Record, playback, the record button, play your images. So if I press play, it'll run through the series of images that I've already selected. As you would have noticed, in the middle of the screen is the image that we're looking at. There's a film strip, so you can go through and grab different images, select them. On the left-hand side, we have the application steps. So the application steps run you through what you need to do to set up a job. Initially, get connected, set up your image, and then you go to set up your tools, which locating your part is the first part, then inspecting your part. So what they've done is they've grouped all of the information here to make it easy for you to learn and understand on how to set up a system. When I run training on this, on the right-hand side, we have the palette, which has help, results, other links and IO that you can see what's going on. But I just get people to, I teach people by going through this software. It has everything in it to get you going. For instance, get connected. It starts with Welcome to Easy Builder, which provides a step-by-step approach to building machine vision applications or jobs. The Get Connected step is used to connect to an Insight vision system and or emulators. So everything you need is here. If I click on the next step here, which is set up image, you'll notice two things. The help has changed to set up image. So it's an active help, whatever step you're on. And you also will have noticed the bottom pane, they call this the application pane, has changed. So what it gives you at these steps, the application pane gives you what you can adjust at that particular step. So they're sort of feeding you what to do. And also with the help here, very extensive. So I train a lot of maintenance people. You know, I say to them, don't worry if you forget, just come into this software, start reading. It should hopefully come back to you. Maybe not in the middle of the night when you're on a breakdown and the boss is behind you, but hopefully. So with the Get Connected step, you can connect to an emulator or a camera. Down the bottom, it'll show you the different laptops that are here. Because I'm on a network in the office at the moment, this is probably one of the other guys, probably Ashan, who's doing some work. His laptop. You can change the emulator to emulate different products. And that's a good thing about this software. It's free. You can download it. I'll send you a link if you don't know where that is. Maybe include that in a after video. And also maybe a link to the recording of this session. So change to different jobs, set up image. This is where you can edit your acquisition settings. So notice on the right-hand side, the setup image step is used to acquire or load an image. Adjust the Insight Sensors acquisition settings, and if your application requires, in real-world units. So the setup image step is everything relating to the image. Where do I want to get my trigger from? The camera. So that's the hardwired trigger, continuous, external, or from a network. So it could be triggered via your PLC, via the network. Do I want to delay the trigger? Maybe your photo sensor is not quite in the right position. Generally, the exposure is the one thing that I do adjust. Because I'm running an emulator, I can't adjust the exposure time, doesn't make any difference. But this is where you can adjust all parameters relating to the image, even to the point of the number of rows that we are looking at. Instead of, you know, this is a 480 by 640 camera. This one, you could cut down and say, I only want to go from row 100, well, not 1000. Now you notice the bottom's cut off, or a bit of the top's cut off. Change that back to 0. Yeah. Oh, we're starting at 100, going down. So you can adjust the number of rows, and that can speed things up. Anyway, we're keeping it simple and straightforward. So the next step, so I'll go through this application here, which is, as we can see, it's a bottle application, and we're doing fill height is the Coca-Cola up to the right top. So with any application, generally, you would want to locate your part, because as you can see, this part is moving backwards and forwards, not up and down. You wouldn't expect it up and down in a bottle application. So let's go to our locate part step. Notice there again, the application pane at the bottom has changed, and it gives us all the location tools that we have at our disposal. So we have a variety of different pattern tools. We have edge tools, edge intersection, blobs, circles. You know, if I was looking at a bottle top, I'd use a circle tool to locate. But nice little description here again. The location tools are used to locate a feature in the field of view and report the found feature's position. So in our application, I'm just going to use the PatMax pattern tool. I've clicked on that. Notice again the description. Locates one pattern feature using PatMax algorithms. Reports X, Y coordinates, angle and score the found pattern. Commonly used as a fixture to orientate other vision tools. Click the Add button to begin. For more information, see the Help palette. So that's what I mean. Everything is here. I hope, generally my goal with training people is download the software, get the emulator key, and play around with it. You're not going to hurt this software unless you take an axe to your computer, and you're still not going to hurt the software. It's going to hurt your computer. Sorry, I should have warned you at the beginning. I try to put humor in, but I'm not that funny. That's why I didn't take up my comedy routine. Anyway, more help. There's more help over here if you want to learn what the vision tools, the different tools will do. Choosing a location tool, for instance, lots of help. It'll tell you about those tools. So very good help. So let's click the Add button. You'll notice, as it mentioned in the notes before, it's a graphical program. This is my model. What do I want to model? This is my pattern I'm going to look for. I'm going to look for the bottle top. And then this up here is my search region. Where do I expect to find it? Expect to find it in that area. You can change the model to be circles, annulus, polygons. You can change the search region to be a circle, annulus, polygon. I'm just going to work with rectangles today, keep it simple. But this is where I expect to find that model during runtime. Click OK. You'll notice it's opened up the property sheet pretty much for this. We have here the Generals tab, which is the same. You can give it a name, find, cap. Under settings, so General tab is the same for every tool. Enables you to give it a name. You can put in a description. Is it a fixturing tool? No, this tool's is going to be our fixturing tool. Under the settings tab, this is everything we can adjust and change for this particular algorithm. So acceptable threshold, how much of a match do I want? Click on results. I want to see, how much of a score, at least 50. Maybe I want to change that to 80. What contrast for this? At least the edges, how much contrast? How much rotation do I want to allow? Well, the bottle top shouldn't rotate more than 5 degrees, but you may have an application where you're looking for something coming down a conveyor and it could be 360-degree rotation. Scale tolerance, how much tolerance? Plus or minus 5%. Yes, the algorithm is very flexible and can handle a lot of variation. But the more of these features that we put in, the longer the processing time. So there are different algorithms we can select. PatMax, we'll just keep it simple today. it's got a score of 99 because it's the part we taught. So they're just, everything you can adjust. That's why I say this environment is a configuration environment. Next, on the right-hand side, you can see the image that's been trained for our reference. This is if you want to change the model region. You can do composite regions where you can mask out particular areas. Might be handy for some applications. And same for the search region. Once you've put a tool down, like I have here, you can see up in the graphic, it's highlighted the outline in green to show the geometric pattern taught, and it also gives the center of the pattern taught, highlights that with the cross. Always good practice. Okay, I've made my location tool. Let's check it out, run through and see what's going on. Hasn't found the cap there. Maybe my angle isn't great enough, or it could be my score's too high because when I trained it, I trained in this here. So it's looking for other features. Where it doesn't match, because the cap, the seal is broken here, it's showing us in red. So a bit of feedback. So that's why, we deploy our vision tool, then test it. Does it work? Could be better because I've taught maybe a bit incorrect. No fear, I want to change because I've included the neck of the bottle as such in the model. It's giving me a lower score than I expect. I come down to model region, maybe train in without that, hit the train button. Now away we go. It's giving me a better score because I'm not getting the change of this here. But that's like any vision application. This software is great for modeling and testing out different ideas. You're probably not going to get it right the first time. Anyway, to finish off this particular application, we come down to inspect part. I want to see if this is here. So click on inspect part. You notice it now brings up the inspect part tools. So all of these tools that we have are grouped. So presence, absence, is something there or not. We have measurement tools, quite straightforward. Counting tools, yep, for counting number of things. Identification tools, that's our 1D, 2D barcodes, OCR. Then we have geometry tools, maths and logic tools. If this and that, it's a pass or a fail. Plotting tools, so we can plot things on the screen. We can give feedback to an operator. We have these image filtering tools. So lots of different things, lots of different tools that we have for us to do. And there again, I'm going to do a presence absence tool. I click on here. I want to check the brightness. So more information here under the description. If I click on brightness tool, what's it do? Determines whether or not a feature is present based on the average grayscale. Click the add button to begin, add. So pop this here. I'm just going to look to make sure that it's dark, to make sure that the liquid level is high enough. Now this is, you can move this around, stretch it. We have lots of different tools. We can rotate this graphic. When I'm happy, tells me here, click the OK button. Oh, notice here the Generals tab, give it a name, fill, height. It's tool fixture. It's automatically linked to the find cap. You'll notice here, find cap, it's linking, it's sending its data into the fill height. So you can see where the information is going and where it's going to. Change the order. It's better by clicking on the link. the software, there's so many different things you can do with the software, and there's about 2 or 3 ways of doing the same thing as well. Anyway, let's test out this. So general tab's the same, range limit. It automatically, this software does a lot of things automatically, like linking this tool to that, but it also puts in plus or minus 5% for our tolerance. Might be enough, might not. Let's go to the next image. Notice how the tool has moved. It's linked to that position tool. That's all done automatically. Yes, we get a fail because we're out of our tolerance. We've got between 11 and 13 is good, and we've got 255. The average brightness of all the pixels in there, as you would expect, is 255. Come back to a good image, the average is 12.8. On the right-hand side, you can see a graph that shows us the spread of pixels going from 0 to 255 in that region. So, like any application, scroll through, check, test, make sure it's doing what it should be doing. Notice that on the one where that's failing, that's, well, we're not checking for that. That's another tool we could place on there, another brightness or a contrast tool. There again, you can see here, because the cap is cocked, which is something else that we want to look for, it's feeding out X, Y, and angle. So this is getting X, Y, and angle out of it as well. So we probably don't want that. There's ways around. We can come back into this tool and say we don't want any rotation tolerance, make that 0. Now, it's not going to, even though when it rotates, it's not going to feed out any rotational tolerance. Look, I'll just quickly grab another set of images. So when you do download the software, it comes with all these different examples. These examples were taken with a Cognex camera. You can run them in the software. Also, for working out if your application can work or not, as an initial trial, you can take images with your phone. It might be 12 megapixels. We're running a 0.5 megapixel emulator. You might just need to shrink it with the program Paint that comes with the software. Okay, here's a bracket. I'm going to do a new job. New job there. Under here, new job. Alternatively, new job. This software package is so intuitive. There's 2 or 3 ways of doing the same thing. I always tell people, what do I do next? Just whatever comes, first thing that comes in your head, do it. So I'll just quickly show you some other tools here. This is a bracket. It's moving around. So I'll use another location tool. Just grab a pattern tool again. You don't have to do a pattern of the whole thing. I can just do a section. That search region should be fine. Now I'm going to go on to showing you some other tools. So measurement tools, great ones to play with, easy to understand. Distance, maybe we're checking the full width of this part. So distance measurement, click the add button. It tells you what to do here. Select 2 features. So 1, 2. It automatically pops on edge tools for us and calculates the distance. If we scroll through our images, all these tools are automatically linked to pattern fixture 1. So as we move, you'll see all the tools are moving for us. That's why I say this is a configuration environment. Best way to learn this software is just get in and have a play. So this one, and as you will find, this one, it didn't find the edge, it's failed. So yes, our tool fails, but I like to actually make a decision and check. So, okay, this is a fail because it hasn't got the extra flap there. This is maybe where I need to come in and change my range limits. So there's a good product, which is 411. Come to the bad one, 390. See, when it puts in plus or minus 5%, 10%, it may not be right for your application. So that's where you may need to tweak and adjust these maximum and minimums for your application. Even though EasyBuilder does everything for us, you still need to check and validate what you're doing. Or maybe make the edge tools larger, like I've just done there. Angles, working out angles, click the add button. I want the angle from there to there to make sure that it's quality control. Easy enough to do. There again, it's automatically put in a couple of different range limits. Also, other different things, measure radius, click the add button. That's what I say to people, just get in, have a bit of a play. There's a bend tool there. I can bend it a bit more to approximate. Double click, it's popped that tool in. It's automatically linked to our pattern tool and it measures the radius 42.142 pixels. You'll notice with these edge tools, they also give us a graph that shows us the rate of change there. I'll pause the recording now.